Good. So we started talking about this thing called bias. We talked about how things can be biased when we look at how we display data. So like different types of graphs can be kind of misleading when you look at them. For example, like the y-axis might be shifted a little bit, or someone might be trying to say that there's a correlation between two things and implying that there's some sort of causation behind it. And then we talked about how bias can be applied in surveys. So like how you ask the questions, how you give out your survey. We talked about bias there. And we also talked about the different types of bias. There were 3 that we kind of talked about. Okay, now we're gonna stray away from the idea of bias. And we're gonna go through a couple words that I might be using through the rest of the semester that kind of stand out a lot. So we're kind of taking a step back here. So I remember talking to you guys about the thing, this thing called a population and this thing called a sample. Is there anyone who can kind of explain what those 2 words mean? In general.
Population is the whole, the sample is a piece.
Yes, and you're Jessica, right? Yep. Yes, that means. Yeah, so the population is the whole thing, the whole amount of people or things that you're interested in. The sample is a piece, so the smaller thing that you're actually collecting data from. Now, when we talk about populations and we talk about samples, we're going to be doing a lot of things with numbers. This is a math class, by the way, anyway. And yes, we are going to use numbers to describe things. Now, sometimes the numbers will describe the whole thing, the population that we're interested in. And then other times the number is going to describe the sample, the small thing that we're taking information from. So we have words for those numbers. If we're talking about a number that describes a sample or the small piece, we're going to call that a statistic. Okay? Now, when we're talking about the entire population and there's a number involving the entire population, we're going to call that a parameter. Okay. Okay, so I have 2 examples for you. Let's go through the first. Okay, this question is saying 57% of the teachers at Central High School are female. Okay. The number that we're interested in right now is 57, and we want to know if it's a statistic, so does it describe the sample, or a population, or a parameter, does it describe the population? I know these questions can be slightly tricky, and the way I like to do this is try to figure out like what my population is before I actually figure out what we're talking about. So let's ask ourselves what the population is. Okay, what is the population? Oh, in this case, Ashley.
Teachers at Central High.
Perfect. The teachers at Central High School. That's the people that we're interested in. Now I can write what the sample is. Oh my gosh, I can't spell sample. Is there a sample in number 1? Okay, yes, female describes like the thing that we're interested in. This, but is there like a small piece that we took out of the population? No, right? There's no, we didn't actually ask a certain amount of people here. It doesn't explain it at least, right? So is 57% talking about the teachers at that Central High, or is it talking about a small piece? About the teachers, right? And I know it sounds confusing because yes, 57% describes how many are female, and I guess that is a smaller segment of the population, but it's saying 57% of the teachers, and the teachers is the whole thing that we're interested in. Does everyone kind of see the difference? Perfect. So is this a parameter or a statistic? Parameter, yay. Okay, let me give you a second example. In this sample, we have 100 surgery patients who were given a new pain reliever. 78% of them reported significant pain relief. Okay, we're interested in 78%, right? We got a population, we got a sample. Are we talking about, or does this question talk about a population or sample. Can you give me one of these and tell me how you figured that one out? Okay, good. The sample is the 100 patients, right? So that was pretty easy because it said it was a sample. Does it really tell you what the population or everyone that we're interested in is? No, right? And I mean, you could guess that it could be all the patients in the hospital, for example, but it doesn't really tell you about a population, okay? So because it says a sample, 78%, what do you think this is, a statistic or a parameter? Statistic, perfect. Okay, so with these questions, I know they can be a little bit confusing with the wording. I'm gonna give you a hint. In any question that asks you about a statistic versus a parameter, if it says the word sample or like polled, or I asked a bunch of people, like you're collecting information, it's a statistic, right? If it doesn't talk about a sample, it's a parameter. Any questions about these sort of questions? Okay, I think you have one of these on your homework, I'm not sure. All right. Okay, some more vocabulary words that we're going to be throwing out. So we have these things, we have things that we obtain and the values of the variables that we obtain. So for example, like if I asked you your exam score, for example, that would be an example of data. Okay. We collect things from the individuals, right? And the characteristics like your age or your major or something like that are the things that we call variables, okay? I think it's easier to describe what these are with an example. So let's just go through this one real quick. Okay, so here we have student 1, 2, 3, 4, 5. I asked them their major, their exam score, and their grade in the class. Okay, who are the individuals in this example? Awesome, students 1 through 5. These are the people that I went in and got the information from. What are the variables? Major, good. Exam score and grade, good. These are like the big things that I'm taking away from each of the students. Major, exam score, and grade. And let's just focus on individual number 1. What is this student's data? Perfect. That's the data for individual 1. So major is psychology. Exam score is 92, and the grade is an A. Any questions on using these sort of terms? Perfect. All right, that wasn't too bad. Let's do one more group of terms that I'm going to be using a lot, and these pop up a lot throughout the rest of the class. 2 types of variables. Okay, 2 types of variables we have. Sometimes we can have numbers that words that things that can be described with numbers, and then we're going to have things that can be described using words. Okay, if we're talking about something called qualitative data, you might also see this written as categorical data. Okay, you're measuring the quality of something or putting something into a category. These are variables that can be described using words. So this is more of a, I'm going to say words. Okay. Now, on the other hand, we have these things called quantitative variables. When we're asking about the quantity of something, we're asking for a number, right? So this is more of a numerical variable. Okay, another word people might be using for quantitative data is measurement data. Because you can measure something. Okay, so if something can be described using words, it's qualitative. If something can be described using numbers, it's quantitative. Let's do some examples here. Let's do the first one. A person's age. How many think this is qualitative? Okay, how many think it's quantitative? Anyone want to explain why? Number, good. Anyone else? Yeah, if I asked you what your age is, you're gonna be like, I'm 21 or I'm 24 or something like that, right? So the answer is gonna be a number. This is quantitative. Okay, I don't know why I wrote this, but I thought it was funny. Okay, someone asked me what flavor of cat I own, and it actually was like, they meant the breed of cat, but they said the flavor. So that's what I mean by this. So the breed of cat. I don't know why I wrote this. Sometimes I try to crack myself up and then I forget that I write it down. Anyway, so what do you think this one is? Quantitative? Qualitative? Qualitative, good. When someone asks you what type of cat you are, you say, you don't say 3, right? You say, I have a domestic short hair or something like that. So this is qualitative. Okay, another one quickly, mileage of a car. Qualitative or quantitative? Quantitative, because the answer is going to be a number, right? Quant. And what about the color of a car? Qualitative, right? You don't say, my car is the color 3, right? You're going to say it's blue or silver or something like that. So this is qualitative. Okay. Any questions on the types of variables? Awesome. Okay, so we're actually kind of done this section of notes. We're actually going to start the next chapter, and we might get out a little bit early because I forgot to bring protractors, which is necessary for this. We'll see how far we get here. Oh, no. So what I'm going to do for the homework, and what I did last semester, is I just had everyone kind of fill out a chart to kind of calculate what they need to do, but you don't actually do the project. But that's a good question. Okay, so I am going to pull up these notes here. So we're dealing with chapter 30.1 now. Remember, we have 2 types of data. We have categorical, which is the qualitative data, and then we have quantitative, which is the measurement data. This chapter is titled Representing Categorical Data. Another word for that, remember, is the qualitative data. Okay, so we want to show how we can represent or maybe graph any data that can be described using words. Okay, now we already talked about the 2 types of data. If you want to write the answer to this, it's, remember, quantitative and qualitative. And of course, this chapter is focusing on the qualitative. The 2 things we're going to do to focus on or to talk about how we can graph or represent qualitative data, we're going to be focusing on the bar graph or the bar chart, which I don't think anyone calls it, but okay. And we're also going to talk about the circle graph, which you probably know as a pie chart. Okay, so we're going to learn about how to do these 2 things, how to make sure that they are done correctly, and so on. Okay, let's do a little example here. We have this retailer, and they accept 4 types of credit cards. We got Visa, Discover, American Express, and MasterCard. And the first thing that I like to do before I even make a graph is make something called a frequency distribution. Okay, and what this is basically a tally chart, and it just shows how many of each thing that there are. Okay, how confident do you think you are on making this? Pretty good. All right, I'm gonna give you like 2 minutes to work on this, and then we'll get back. Right, I think I see most people finishing up here. Okay, so yes, I can do a tally chart, but what I'm gonna do is just write the whole number of observations next to it because it's easier to work with numbers. How many MasterCard did we have? 11, perfect. How many Visas? 23, perfect. American Express? 9, and Discover? 7, perfect. Okay, without looking at the question, how do you think I could find the total number of observations? Megan.
You count how many are like the vertical and then how many are horizontal.
Times them or?
Oh, we can add all those. I was looking at the.
Oh, okay, I
graph
see.
side.
I see what you're, okay.
Yes, you could do like 1, 2, 3, 4, 5, and then like multiply the rows times the columns.
What's another way? Paris? Yeah, right, because since we have a tally chart of like MasterCard here, if I tallied up like 11 things, this would literally, if I did this for each one, okay, I'm not gonna do it, but it would literally have one line per observation on our data sheet, right? So basically we're saying there's 11 MasterCards, 11 Visas, 9 American Express, and 7 Discovers. There's no other thing that we're leaving out. So if I literally just take 11, 23, 9, and 7, add those together, I should get 30, which is the total number of observations. Okay. Oh, what was your question? Yes. Wow. I was so confident. I was so confident when I said that. Thank you so much. Okay, yes, there are 50 observations. So even if you aren't given that there's 50 customers and you're not even given the data, you can still find the total based on this tally chart. Okay, awesome. Let's make a bar graph. Right now, I think we're all pretty good on making bar graphs. I think we've all seen them before, but we're gonna do one just to make sure we like have the correct way of making it. So of course, we make a bar graph. We want an X and Y axis. There's no negative number, so I'm just gonna, I don't know, make a line here and maybe a line here. Oh my God, that was really bad. Let's see. There we go. Okay. Now, of course, a bar graph needs a title, right? I'm not very creative, so I'll just title it credit cards. I'm not going to get too much on you for this, but what should my x-axis be? What should it represent? Not quite.
What do you say, X or Y?
The x-axis, sorry.
That should be what credit cards.
Yeah, the x-axis should be the categorical variable. So the thing that can be described in words. So this is actually going to be like the type of credit card. Okay, and on the y-axis, we have the amount, right? The number of customers. Okay. Now, what I'm going to do here is I kind of want to make my bars like maybe 2 blocks, okay? Just looking at how much space I have since I have 4. The one thing about making these graphs is when we have a bar graph, we want there to be a space between the bars. Okay, so that makes a bar graph a bar graph. You don't want to have no space between them. So I'm not even going to label the x-axis yet. Let's say I want to label the y-axis and I want to label like every second block. What should be my scale here? So what should each 2 blocks represent? I got 0 down here. Maybe 10. 10 would be good. Let me just take a peek at how much we need. If I did 10, this would be 10, right? And this would be 20. This would be 30. Don't write this down yet. Our highest number is like 23. So this might be a little bit too smushed. Of course you could do that, but I wouldn't take off points for that or anything. But nice guess, Paris. 2 would be okay, but I think I might run out of room. I might not reach 23. 5 sounds about right. Were you about to say that, Megan? All right. I'm gonna do 5. Now, if you decide a different length, there's no like perfect length. So if you decided to do that, I wouldn't care too much, but let's do 5, 10, 15, 20, and 25. Okay. Next, what I want to do. Since I want my bars to be length 2, I'm going to count 1, 2. I don't know if you can see that. 1, 2 away. I'm going to erase that. And I want to make my MasterCard a bar that's kind of 2 blocks wide. Okay, they don't have to be 2 blocks wide. I'm just saying that because I think that's how it will fit on this sheet. Okay, MasterCard was, how many MasterCards did we have, by the way? 11, perfect. So I think I'm gonna approximate 11. I think that's around this height, right? I'm gonna make my bar. If you're feeling fancy, you can fill it in. Okay, so that's gonna be my first bar. Okay. My next bar is going to be a Visa, okay? One thing that, you know what, let's just do this and I might do something wrong, so don't write down anything yet. We had 23 Visas, right? So I want this bar to be length 23, which is about here. This would be wrong, so I would mark you wrong for doing this. If you made the bar here, okay? A bar graph always has spaces between the bars. So I'm gonna erase this and actually put the Visa 2 blocks to the right. Okay. I'm gonna label that Visa.
It's one block over, is that fine?
If it's one block over, it's fine.
As long as it doesn't touch.
Yes, as long as they don't touch, because there's a graph where the bars actually do touch. It's called a histogram, and that's what a little bit different than a bar graph. All right, and I guess you can kind of figure out what we're doing next. We can do the American Express, which has 9, right? And then we have Discover, which has, was it 8, I think? Or was it 7? All right, and then we made our bar graph. So just to summarize, I think the biggest thing that we wanted to look out for a bar graph is that bar graphs have spaces between the bars. Spaces between bars. And that's kind of the most important thing you should keep in mind when looking at a bar graph, trying to figure out if something is or is not a bar graph. Any questions on what I've done? Sounds good. All right, let's move on to our next type of graph, which is the pie chart. These are a little bit harder to make, and I'll kind of explain why. Okay, pie charts deal with not just like how many we have, but it also talks about percents. When you look at a pie chart, it's very easy to figure out like what percent of the whole that we're at, usually because the percentage is like actually displayed. So if we wanted to find the percent of observations that we have, the first thing I would do is look at the proportion of observations, which is a fancy way of saying like a decimal or a ratio, okay? Hard to kind of explain in the abstract, but you take the total number of observations that you have of that type, like the total amount of MasterCard, for example, and you divide by the entire total number of the sample. So in this case, the total number would be 8. Okay, once we get that proportion, we need to translate that into the angle in a circle. So for example, if the proportion was 0.5 or 50%, for example, we had 50% of, I don't know, dogs in our sample. Would that translate to an angle of 50 in our pie chart? I see a yes, see a no. Anyone want to explain? Julie.
A circle is 360 degrees total. So like 50% of that.
You're upset. 180, right? Like half of a pizza is 180 degrees, right? So there's some sort of translation we have to do between the percentage that we have and the angle in the circle that we actually want to draw, okay? Somehow 50 turned into 180, okay? Now I think I heard it, the total number of angles in a circle is 360, right? The way I memorized this is really weird. I didn't memorize this until like 2 years ago, but a whole circle or half a circle is 180 degrees. Kind of like that song that says, did a whole 180 and then you like turn around. Okay, if you do that again, you're at 360, right? So just add 180 twice and you did a full circle. Okay, so total number of angles in a circle is 360 degrees. If you want to find the angle in a pie chart, you're gonna take the proportion of observations, so like 50. not 50, a 0.5 if you have 50. And you're gonna multiply that by 360 degrees. So you're just multiplying it by the total number of angles in the circle. That's the angle that you get. Okay. Any questions so far? Let's do an actual example. I think it might make a little bit more sense. Okay. So here I have a chart. I have the types of cards. I also put the number of observations next to it. What we're going to do is we're going to calculate the proportion of observations for each type of card. And then we're actually going to calculate the angle in the pie chart. And the next class, we can actually figure out what it looks like. Okay. Remember the total number of observations was 50, even though I wrote 30. And we got that by adding up the total number or all the number of observations. How would I find the proportion of observations for MasterCard? Perfect. The number of observations, what we're interested in, over the total. Okay. Now, if I'm looking for a proportion, technically that's right, but I want to figure out a decimal so I can multiply it to find my angle. Okay, so if someone has a calculator, would you mind actually doing that division? Awesome, 0.22. Okay. Once I get this proportion, this is the proportion of observations that are MasterCard. So 22% is MasterCard. Okay, how would I find the angle in my pie chart? Perfect. I'm going to take 0.22 and I'm going to multiply it by 360. And what do I get?
79.
Perfect, 79.2. Okay, so the angle in my pie chart is going to be 79.2 degrees when I finally construct that pie chart. Any questions? I'm going to give you some time to do the other three. This is very similar to something you'll see on your homework. All you have to do is divide by 50 and then multiply by 360. I think I see people finishing up. If you're still working, that's okay. Can someone tell me the process they did to find the proportion of Visa? So what did you divide? Oh, are you Alyssa? Yes. Perfect.
So for the proportion of observations, I did 23 divided by 50,
Mhm.
and I got 0.46.
Perfect. And do you want to go ahead and do the angle too?
Sure, I did 0.46 times 360,
Mhm.
and I got 165.6.
Awesome. 165. Did that wrong? 0.6 degrees. Everyone agree with Visa? All right, Ken. The process I think is pretty good. I think we're all good on this. Can someone tell me the number they got for the proportion for American Express? Paris?
The answer.
Yeah.
0.18.
Awesome. Everyone agree? What about the angle? Huh? Okay. What about discover for the proportion? Gosh, Valerie? Yes. All right. And the angle? 50.4. Does everyone agree with what we have here? Okay. On a test, quiz, or homework, all I'm going to do is give you this. So all you really need to know is how to find the proportion and how to find the angle. I do think it's useful to actually go through making a pie chart. So we'll do that next class. I forgot my protractors, which sucks. So I'm actually going to let you out a little bit early since I forgot my stuff. But it's nice because it's Friday. Get out early. All right. Have a great weekend. We don't have class on Monday, so don't come here on Monday. And I will see you on Wednesday.